understanding images is a complex process that has traditionally been the domain of human perception. However, with recent advancements in artificial intelligence, particularly in the realm of large language models, LLMs, machines are increasingly capable of interpreting and comprehending images in ways that mimic human understanding. In this essay, we explore how LLMs understand images, the challenges they face, and the implications of this capability. At their core, LLMs are natural language processing models that excel at understanding and generating human-like text. They have been trained on vast amounts of text data and have learned to recognize patterns, understand context, and generate coherent responses. However, understanding images poses a unique challenge for LLMs, as images consist of pixels rather than words and convey information in a different modality. To bridge this gap, researchers have developed techniques that enable LLMs to understand images through a process called image captioning. Image captioning involves feeding an image into the LLM and prompting it to generate a textual description of the image. This description typically includes details about objects, scenes, actions, and relationships depicted in the image. The process of image understanding by LLMs can be broken down into several key steps. Feature extraction. Before processing images, LLMs require a representation of the image that can be understood by the model. Convolutional neural networks, CNNs, are commonly used to extract features from images. These features capture information about shapes, colors, textures, and other visual elements present in the image. Integration with language model. Once the features are extracted, they are combined with the language model, which is typically a transformer-based architecture like BERT or GPT. The LLM processes the combined information to generate a textual description of the image. Context understanding. LLMs utilize their understanding of language and context to generate meaningful descriptions of images. They analyze the relationships between objects, infer actions and events, and incorporate common sense knowledge to produce coherent captions. Evaluation and refinement. The generated captions are evaluated based on their relevance, accuracy, and coherence. Feedback from human evaluators or automated metrics helps refine the model and improve its performance over time. Despite their impressive capabilities, LLMs still face several challenges in understanding images. Ambiguity. Images can be interpreted in multiple ways, and the same image may evoke different descriptions from different individuals. LLMs must grapple with this ambiguity and generate captions that are both accurate and contextually appropriate. Complex scenes. Images often contain complex scenes with multiple objects, interactions, and background elements. LLMs must learn to focus on relevant details and filter out irrelevant information to produce concise and informative captions. Common sense reasoning. Understanding images requires more than just visual recognition. It also involves reasoning about common sense knowledge and understanding the context in which the image is situated. LLMs must integrate visual information with linguistic and world knowledge to generate accurate descriptions. Bias and fairness. LLMs are susceptible to biases present in the training data, which can lead to unfair or inaccurate descriptions of images, particularly for underrepresented groups or marginalized communities. Addressing bias and promoting fairness in image understanding is an ongoing challenge for researchers and practitioners. The ability of LLMs to understand images has significant implications across various domains. Accessibility. Image understanding technologies can make visual content more accessible to individuals with visual impairments by providing textual descriptions of images. Content understanding. LLMs enable machines to analyze and interpret visual content at scale, opening up new possibilities for content moderation, image search, and visual storytelling. Human-computer interaction. Improved image understanding capabilities enhance the interaction between humans and machines, enabling more intuitive and natural interfaces for tasks such as image retrieval, content recommendation, and virtual assistants. Creativity and expression. LLMs can be used to generate creative and expressive descriptions of images, enriching artistic endeavors and fostering new forms of human-machine collaboration in fields such as digital art and creative writing. Conclusion. The ability of LLMs to understand images represents a significant milestone in the development of artificial intelligence. By bridging the gap between visual and textual modalities, LLMs pave the way for more sophisticated and nuanced interactions between humans and machines.